Up a cosmic cold case. For nearly 100 years, scientists have been completely stumped by a huge contradiction. How does the universe build these incredibly complex, ordered structures out of what should be pure destructive chaos? So today, we're going to follow the clues and see if we can find the answer. So this is the central question, right? If the main ingredient for building pretty much everything in the cosmos is chaos, how in the world do we get something so beautifully ordered? It's a paradox that has had astrophysicists scratching their heads for decades.
Okay, let's lay out the case file. On one hand, you have our prime suspect, cosmic turbulence. It's a destructive, chaotic force. But then you look at the evidence, what we actually see scattered all across the cosmos, and it's the total opposite. These vast, structured, and super-ordered magnetic fields. So how does the first thing possibly create the second?
And that, right there, is the heart of the matter. It's this fundamental cosmic contradiction. And to even begin to solve this puzzle, we first have to understand the sheer scale of our, let's call it, crime scene.
I mean, just think about it. Our own planet, the sun, our entire Milky Way galaxy, they all have these massive, organized magnetic fields. And these fields aren't just some background static, no way. They shape the solar wind, they guide particles zipping through space, they influence how entire galaxies are born and grow. They are absolutely fundamental, and yet, their origin story has been a huge question mark.
The lead author of the study we're looking at, Bindesh Tripathi, he framed the challenge perfectly. He basically asks, how does a force that's known for tearing things apart end up building something so huge and so coherent?
And look, this isn't a new puzzle. For decades, scientists have been wrestling with something called the dynamo problem, and it has been a really, really tough case to crack.
Yeah, 70 years. That's how long this one question has been one of the most persistent and frustrating mysteries in all of plasma astrophysics.
And you can just feel the frustration in this quote from the study's senior author, Paul Terry. For decades, pretty much every computer model they ran would spit out the exact same result, a messy, chaotic magnetic field on a tiny scale. It just didn't look anything like the grand, orderly structures we actually see out there in space.
So, after 70 years of hitting dead ends, what changed? Well, our cosmic detectives found a new lead, a missing ingredient that looks like it cracks the case wide open.
And here it is. The key piece of evidence is something called a velocity gradient. Now, I know that sounds pretty technical, but the concept is actually really simple. It's just a sudden, sharp change in speed between two things moving right next to each other.
Here's the perfect analogy to make it stick. Imagine a cyclist just cruising along. All of a sudden, their front wheel hits a curb and stops instantly. But the rider, right, their body keeps moving forward. That abrupt difference in speed between the bike that stopped and the rider who's still in motion, that's a velocity gradient. Now in space, we're not talking about a bike and rider, of course. We're talking about layers of superheated plasma moving at drastically different speeds, shearing past one another. So, armed with this new clue, the research team decided to run the experiment. But not in a lab, no. They did it inside one of the most powerful supercomputers on the entire planet. And the scale of the simulation is it's mind-boggling. To even get started, they needed to build a virtual universe with over 137 billion individual grid points.
And each of those points generated a crazy amount of information, totaling 1/4 of a petabyte of raw data. That's enough data to fill hundreds and hundreds of modern laptops.
And to process all of that, well, the simulation took nearly 100 million hours of computer time. This is one of the most detailed cosmic recreations anyone has ever attempted. So after all that work, what did they find? Well, when the researchers kept that velocity gradient steady and constant, something incredible happened. That steady shearing force acted like a cosmic organizer. It started stretching and pulling all the small, tangled magnetic field lines, preventing them from breaking down and instead lining them up into these huge, powerful, and ordered structures. But, and here's the kicker, when they let that gradient weaken, they got the same old result, just a messy, chaotic soup. That steady gradient, it was the secret sauce.
Now, cracking a 70-year-old case is a huge deal all by itself, but the implications of this discovery, they go far beyond just solving a long-standing puzzle. First off, it solved another mystery. See, back in 2012, a real-world plasma experiment in a lab produced some really puzzling results that no existing theory could explain. But this new model, with its velocity gradient, it aligns almost perfectly with that old data, which gives the simulation incredible real-world credibility. And here's why this matters to all of us. This breakthrough could fundamentally change how we understand the most extreme events in the cosmos, like the violent mergers of neutron stars or even how black holes form. And closer to home, it could lead to much better predictions for solar flares and space weather, the stuff that can threaten our satellites and power grids. It is a huge leap forward.
So we end on this thought. For 70 years, the answer was basically hiding in plain sight, a simple rule governing all the chaos. And it really makes you wonder, doesn't it? If a principle this elegant can organize the universe on such a massive scale, what other secrets are still out there, just waiting for us to ask the right question?